Hey guys, this is Jaime. I have right here a project I worked on late last night, and I decided after tons of thinking of what I wanted to do for my winter break, I decided to make an expression parser. And a little bit more than that, I want to make something that's similar to Wolfram Alpha in a sense, where you can simply input an English sentence and provide a result. So, like say, what is the area of a circle with a radius 5? Obviously, it's pi r squared, so you return out 25 pi. There are different things you could do. There are variables you could add in. Currently, I decided to work on the actual base part. What I mean by that is just simply something that I could input a mathematical expression, strictly a mathematical input, and then receive an output. So I have all the classes written already, but I'm going to go ahead and write this part, because I haven't written it yet. So I plan on making this a bit more visual, so I'm going to add in a little bit of GUI stuff. GUI, I say GUI. And actually I don't think this is going to take too long. So I'll scan that has next line. I'm going to go ahead and say, and then let's just say that we have a method evaluate, and put some parentheses around it, plus line, plus that, new line, and equals. So we're going to go ahead and call this evaluate method on our line, which should be an expression, and I'll make the class here, or not the class, the method. So I'm going to return a double, and evaluate is going to take an expression as a string, and I'm going to return a long string of methods. So I'm going to have something called a syntax tree. It's going to take in a syntax node as its parameter, and I'm going to evaluate that. So what I'm basically doing is, here, let me explain it afterwards. What do I need to do next? I believe it's notation converter to postfix, and then provided the infix. So I don't have an infix yet. Notation converter. Let's see. We're going to have to go to math tokenizer. Tokenize the expression, and then this one notation converter, compile to node, autocomplete. Sometimes it's helpful, sometimes it's not. And I think we have to import everything. So there we go. Alright, so I guess we'll go to the innermost first. We have math tokenizer.tokenize expression. So all that does, it takes a simple string. It checks to see each component, so it checks for separators, parentheses, values such as any integer or double value. You can also include scientific notation as well. It also includes variables and word functions, so like sine, cosine, and things of that nature. So once you separate those, it provides a list of tokens, and with those lists of tokens, you use notation converter to convert that infix expression into postfix. So normally the string is read as infix, so 3 plus 4. If we were to put 3 plus 4 into the tokenizer and then turn it into postfix, it would be 3, 4 plus. Surely those with more knowledge already knows that. And then after we have our postfix expression, we're going to compile to node. So what that does is it takes the current postfix expression and it puts every single item on a stack. Every single time you see an operator, it takes out the corresponding values it needs to. So if it was a unary operator, it would take out one operator and perform the operation. So square root of 25, that would be 5. So every time, like say, you have 5 and then square root, that would be the square root of 5 in postfix. So you add on 5 and then you put on square root's a function, it's unary, take off the 5 and perform the operation. And it compiles all of that into a single tree, so I'm not actually performing the operations, I'm putting it into a tree for later reference. And then once I put it into the tree, I create a syntax tree so I can be able to traverse the tree and evaluate it, just simply doing order and traversal. So I believe this works. I'm going to test it. So let's just go with my 3 plus 4. Yep, 3 plus 4 evaluates to 7. So maybe something more complicated, or not really complicated. Cosine of 0. That is 1. Huh. So I guess this is going in as radians. Let's see, what else can we do? We can do 3 to the 3 plus 2.2, 2.3, I almost said 2.2. I don't know if that's right, but I'm going to assume so, since 3 to the 5th is around, not really around that, but somewhat close. Oops. What else can I use? I can use floor 3.4, CLO 3.4, and round 3.4. Those are all working great. Also, there is no spacing requirement whenever the expression is parsed into the math tokenizer. It removes all spacing, so everything should be good there. Let's take, you can do tangent, so tangent of sine of 0, 0. That one's obvious. But yeah, I believe, oh, square root function, 25. 5. That works out great. Alright, so, looks like everything's working great. I need to go in, figure out what I need to clean up. I kind of don't like the current way I'm tokenizing everything, or not tokenizing, but how I'm storing it as a token. It doesn't allow me to add unary minus yet, so I can't necessarily do absolute value, like of -5. So there are a few things I need to add in, and then later on I'm going to add the expression. So I'm going to add a function called solve where you can simply have variable bindings, so like say x equals 4, and you traverse the tree and you adjust every single value. Once you adjusted every single value, you go ahead and go back and evaluate it, but when you evaluate this time, you basically perform algebra to separate the unknown variable so you can figure out which value it is, and I think that would be pretty neat. So that's all for now. This is my first video, so I hope it went somewhat alright, and thanks for watching.